Now let us start discussing the first exercise of trigonometric functions, a 3.1 exercise. The first question, find radian measures corresponding to the following degree measures. So 4 bits are given. We have to write those degree measures to radians. So we will use the conversion relation, like 25 degrees is how many radians. So we will use the relation degree by 180 is same as a radian upon pi, and in place of degree we will write 25, and then we will go for a simple cross multiplication, and then we will get r as a 25 pi upon 180. Pi we can write as 22/7, or whenever we answer an angle in terms of radians we can leave it in terms of pi. Why? Because 0, pi by 2, pi, 3 pi by 2, 2 pi. So we can know radians, angle in terms of pi also, the way we know about in degrees. So 5 table, 5 5s 25, 5 3s 15, 6. So 5 pi by 36. 25 degrees is 5 pi by 36 radians. That's the first bit. The second bit is minus 47 degree 30 minutes is how many radians. Minus talks about the clockwise rotation of the terminal ray with respect to initial ray. So don't consider minus in the calculation. So it is the rotation direction, like anti-clockwise is positive and clockwise rotation of terminal ray with respect to initial ray is considered negative angle. So we have to first write 47 degree 30 minutes in common unit, means everything in degrees. So here recall that 60 minutes was 1 degree or is 1 degree. In that case 30 minutes is how many degrees? A simple cross multiplication, that is 30 upon 60 means 1 upon 2 degrees. So 47 degree 30 minutes is actually 47 degrees plus 1 by 2, everything in terms of degrees, which in turn is 95 by 2 degrees. Now we will write 95 by 2 degrees is how many radians? That is the question right now. So we will use the same relation, degree upon 180 is radius upon pi, and in place of degree we will write 95 by 2 and cross multiply pi. This in turn will give us radians as 95 pi divided by 2 times 180. We can go for 5 table, 5 1s, 5 9s. So 5 19s is 95, then 5 3s 15, 6. So further division is not possible. So 19 pi upon 72 minus 47 degree 30 minutes is minus, means negative of 19 pi upon 2 into 36, that is a 72 radians. The third bit, 240 degrees is how many radians? We will use the relation degree by 180 is radians upon pi. In place of degree we will write 240, and we see for the simplification. So 6 3s 18, 6 4s 24. So on cross multiplication pi will be multiplied to 4. So radians, in terms of radian, it is 4 pi by 3. 240 degrees is 4 pi by 3 radians. 520, the fourth bit, 520 degrees is how many radians? For that, the same relation, the angle in terms of degree divided by 180 degree is a radians divided by pi. So this degree cancels here, fine. Then 2 9s 18, 226 is 52. Further division is not possible. We will only cross multiply. So we will get 26 pi by 9. 26 pi by 9. 520 degrees is 26 pi by 9 radians. And then 3.1 exercise, second question. Second question is find the degree measure corresponding to the following radian measure. That means angles are given in terms of radians. We have to convert them in terms of degrees. So keep this in mind. We will get in terms of minutes, seconds, but we have to bring everything to degrees. So 11 by 16 radian is how many degrees? For that, I prefer to use a rough space, and then I will write this in fair space. Now the second question is, we have to write the degree measure of an angle which is given in radians. So we'll use the same relation, degree upon 180 is radian upon pi. In this case, pi is 22 by 7. So radian is 11 upon 16 and pi is 22 upon 7. How this right side appears? 11 into 7 by 16 into 22. So this we will simplify. So 11 ones, 11 twos, that's all. And later this 180 will transpose the other side. We'll get 180 into 1 into 7. So this by 16 into 2. So 2 ones, 290. 2 table once again, 2 eights, 16, 2 45s, 90. So we have 45 into 7, 7 5s 35, 3 in hand, 28, 29, 30, 31, 315 by 8 degrees. So 315 by 8 degrees has to be written like whole number, not like this. So we'll go for long division, 315 by 8. So 8 threes, 24, because 8 fours 32, greater than 31. So here we will get 7 and 5. So 8 nines 72, the remainder is 3. So we can write the degree form of 11 by 16 radian as a 315 by 8 degree is actually 39 3 by 8. 39 degree 3 by 8 degree. Now we'll also remember that 1 degree is 60 minutes. So we have to write the answer ultimately in terms of degree, minute, second. So 1 degree is 60 minutes. So we can write this answer as 39 degrees and 3 by 8 multiply 60 here, so that this comes in terms of minutes. 6 3s 18, so 180. 180 by 8. Let's divide. 8 2s 16. So we get here 2 0. 8 2s once again 16. So we have 4. So 180 by 8 minutes can be written as 22 4 by 8. So 39 degree plus 22 minutes 4 by 8 minutes. 4 by 8 means 1 by 2 minutes. Now we have to convert this 1 by 2 minutes to seconds. We have here 39 degrees, 22 minutes and 1 by 2 minute. So we'll remember here that 1 minute is made up of 60 seconds. So here 1 by 2 minute means in place of 1 minute we will write 60 seconds. So 60 second by 2 is 30 seconds. So 11 by 16 radians is 39 degree, 22 minutes and 30 seconds. So calculation I have done in rough space. I'll fare it here. 11 by 16 radians is 39 minutes, 39 degrees, 22 minutes and 30 seconds. Now let's go for the second one. Minus 4 radians is how many degrees? So I'm doing that in rough space. Minus 4 radians is how many degrees? We'll use the relation degree upon 180 is radian upon pi, and we cross multiply. Pi is a 22 by 7. So in terms of degrees, it is 4 times 180. 7 also comes here, denominator 22. So we have 2 11s. In terms of degrees, it is 360 into 7. 360 into 7 upon 11. Let's multiply this. 7 6 42. 4 in hand 21, so 25. 2520 by 11 degrees. But we are not supposed to answer in degrees like this. So we have to literally divide them. 2520 divided by 11. So 11 2s 22. Then we get here 3. 2 comes down. So 11 3s 33. So we still should be going with 2 only. 22. This turns out to be 10 and drop down the 0. 11 9s 99 and we have a remainder of 1. So 2520 by 11 is actually 229 degrees and 1 upon 11 degree. So we get here 229 degrees and 1 upon 11. 1 upon 11 degrees. And we know that 1 degree is 60 minutes. So now we will divide 60 by 11. How to divide 60 by 11? 11 5s 55 and the remainder is 5. So 60 by 11 is actually 60 by 11 minutes is actually 5 minutes. This is minutes. 60 seconds is 1 minute because this is a set. 5 by 11. Everything is in terms of minutes. So 5 minutes, 5 by 11 minutes. This part to this part we have to multiply 60. So because we want in minutes also. 1 minute is 60 seconds. So 5 minutes is 5 into 60 seconds. This turns out to be 229. It's not product. It's a combination like 5 minutes. 5 into 60. 5 6 30. An extra 0 by 11. This is in seconds. Now if we divide, we will get in terms of seconds and further microseconds will go for. 300 we are dividing by 11. 11 2s 22. So here 8, here also 8. 11 7s, here 8 and 0. 7 77 3. So this process continues, but I'll stop it here itself with the answer that minus 4 radians is actually minus of 229 degrees, 5 minutes and 27. So 27 seconds. So minus 4 by 11 radians is a minus of 229 degrees, 5 minutes, 27 seconds. The next bit is 5 pi by 3 radians is how many degrees. So I am doing it here itself because this is a simple problem. So degree upon 180 is radian upon pi. So in place of radian I am writing 5 pi by 3. So 3 comes down times pi. So you can cancel pi. Here 3 ones, 3 6 18 0. Now we have to only cross multiply. So 60 into 5. 60 into 5 is 300. So 5 pi by 3 radians is actually 60 into 5 degrees. Means 300 degrees. Similarly 7 pi by 6. So once again degree upon 180 is a radian. Radian is a 7 pi by 6. 6 comes down and denominator r by pi. So that pi is in the denominator. So pi cancels. 6 ones. 6 3s 18 0. Now we should only cross multiply. 7 into 30 is 210. So 210 degrees. Now the third question. A wheel takes 360 revolutions in 1 minute. 360 rounds it turns in 1 minute, means 60 seconds. Through how many radians does it turn in just 1 second? So I wrote some details here. I'll make it, this is actually a very simple question. In 1 minute, 360 revolution. 1 minute is actually 60 seconds. Number of revolution is a 360 revolutions. In that case, the question is about how many radians does it turn in 1 second. So in that case, in 1 second, how many revolutions it turns? Just go for a simple cross multiplication. The unitary method, 60 revolutions into 1 second upon 60 seconds. Second cancel and our answer will come in terms of revolutions. So 636. So in 1 second, 6 revolutions. The question is, by how many radians does it turn in 1 second? In 1 second it takes 6 revolutions. So by what angle it has turned? You see, every time one round is over, the angle covered at the center is a 2 pi. So 6 revolutions. So 6 times 2 pi. 6 times 1 revolution, angle covered in 1 revolution is 2 pi. So this turns out to be 12 pi. Question number 4. Find the degree measure of the angle subtended at the center of a circle of radius 100 centimeter by an arc of length 22 centimeter, pi is 22 by 7. So fourth question, we have to find what is the angle subtended in terms of degrees by an arc whose length is a 22 centimeter of a circle whose radius is 100 centimeter. We know that theta is equal to L by R. Length of the arc is 22 centimeter. Radius of the circle is 100 centimeter. This on standard form is 2 table 11 by 50. So angle subtended by arc of a circle at the center is in terms of radians. So this angle is in radians. So we have to give it a degree measure. Since degree upon 180 is a radian upon pi, and this angle is in terms of radians. So this is 11 by 50. Pi we are supposed to take it as 22 by 7. So this in turn is a degree upon 180 is 11 into 7 by 22 into 50. Fraction divided by fraction, we get something like this. So 11 ones, 11 twos, 2 nines, 18. Okay, so in terms of degrees, it is 9 sevens, 63 upon 5. We have to write this properly in terms of degrees as well as minutes. So 63 by 5, when we divide, we'll go for long division. So 5 ones, 5 twos. So this is 12 degrees and 3 upon 5 degree, but 1 degree is 60 minutes. So times 60 when we do, we get the answer in terms of minutes. So 5 ones, 5 twelves. So 12 degree, 3 into 12, that is 36 minutes. Now the fifth question. In a circle of diameter 40 centimeter, if diameter is 40 centimeter, radius is 20 centimeter. The length of a chord is 20 centimeter. So there is a circle whose radius is 20 centimeter and there is a chord whose length is also 20 centimeter. We are supposed to find length of minor arc of the chord. So I'm just drawing a diagram related to this. So there is a circle whose radius is 20 centimeter. There is a chord length is also 20 centimeter. We are supposed to find length of minor arc. Minor arc is in this zone A to B. So we are supposed to find this. So what angle does this arc subtend at the center? Theta. And what is theta here? We have triangle AOB, which is an equilateral triangle. So equilateral triangle subtends all the three interior angles will be 60 each. So central angle is, this one is a 60 degrees. How to find length of the arc? We have formula for length of the arc, which is 2 pi r theta by 360. Let's substitute all of them. Radius is 20, theta is 60, pi we can take it as 22 by 7. So we have here 2 into 22 by 7 times 20 times 60 upon 360. So here 6, 36. We can have one more cancellation, 3. So it is 20 divided by 3 pi, or we can write it as 22 into 20 upon 3 into 7, that is 21. So this we can further multiply and we will get 440 upon 21. Length of the arc is 440 upon 21 centimeter. So length of the arc is this we can divide also. So length of the arc is 440 by 21 centimeter. Question number 6. If in two circles, when we see the word two circles, its meaning is the circles have different radius. The arcs of same length. So there are two circles but length of arcs are same. Subtend angle 60 degrees and 75 degrees at the center. We are supposed to find ratio of their radii. So I have drawn the diagram. So these are two different circles. That's why their radius are different. Small letter r, capital letter R. But the lengths of arcs are same. So LL, I did not write L1, L2. These same arcs subtend different central angles. With this information, we have to find ratio of the radii of the two circle. Means we are supposed to find small letter r upon capital letter R. Now we will start with length of the arc formula. So since length of the arc is a 2 pi r theta by 360. So lengths are same. So this is length of arc of first circle and length of arc of next circle be 2 pi capital R theta by 360. And we know that the first case theta is 60, second case theta is 75. Since lengths are same, means left hand sides are same, so we will equate the right hand sides. When we do so, we will get 2 pi r 60 upon 360 is 2 pi r 75 upon 360. So they are in degrees. Now we'll see how to further simplify this. 2 pi can be cancelled on either sides. 360 can be cancelled on either sides. So right side is capital R. So we want ratio of the radii. So the small letter r is in the left side, that is the radius of the first circle divided by radius of the second circle. Is right side we are only left with the number 75 and left side the number is 60. So that we can transpose the other side. Go for 5 table. 5 15s 75 and 5 12s. Then 3 4s 3 5s. So ratio of the radius of the two circles is 5:4. The last question of exercise 3.1, the question says find the angle in radians through which a pendulum swings if its length is 75 centimeter and the tip describes an arc length of 3 bits are given. These are arc lengths. So related to this, I have drawn the diagram. So this is that pendulum that is taken to the extreme position, and during that time the angle between mean position and extreme position is theta. Length of the pendulum is actually radius of the circle. Like if this pendulum completes a circle, then that circle's radius is length of the pendulum. Arc length is from this location to this extreme location, whatever is the distance traveled by the tip, that is arc length. So we have to find what angle we have to find angle in radians. So we know that theta is L by R, and using this formula, whenever we find angle, the angle will be in terms of radians. So we have to tell angle in radians only, so not much calculation is involved. Length of the arc in the first case is 10 centimeter and radius of the swing is 75 centimeter. So we can go for 5 table, 5 twos, 5 15. So 2 upon 15 radians. About the second one, theta is L by R. Length is 15, radius is 75, so 15 ones, 15 fives, so 1 upon 5 radians. And the last one, Angle subtended is theta is once again L by R. Length of the arc is at 21 centimeter. Radius of the swing means length of the pendulum is radius of the circular path of the pendulum if the pendulum completes the circle is a 75. So we can go for 3 sevens, 3 2s and 3 5s. So 7 upon 25 radians. So this completes the first exercise, and then we will have the next concept on trigonometric functions. We will see the trigonometric functions in the various quadrants, their values, their signs in fact. So that we'll do. Then we will learn about graphs of trigonometric functions, and then we will go to 3.2 exercise.